Hello everyone. Last class I had taught you different functions and graphical representation of those functions. I had taught you 5 functions. Now today I'll start with modulus function. What is modulus function? A function mapping a function R mapping from R to R is defined as modulus function if fx equal to mod x, where x belongs to R. The value of fx is negative for each non-negative value of x. What is that? The fx equal to x if x is greater than equal to 0, and fx equal to minus x if x is less than 0. Here, how it is? If you present it graphically, for every positive value of x, it will be y will be positive, and negative value of x is y will be positive. So see here, y is equal to, here y equal to this is minus x, and here y equal to plus x. Now see, what is the domain of this function? Domain of this function is, that is x value is always a real number, and what is the range of? Range is 0 to infinity. Now what are the observations of this? This is symmetrical along, this graph is symmetrical along y-axis, and this is above x-axis. This graph passes through origin, and in first quadrant it is coinciding with identity function. What are the observation I told you? It is above, it is symmetrical along y-axis, it is above x-axis, passing through origin, and coincides with identity function in first quadrant. Identity function in first quadrant. Now let us come to signum function. What is signum function? The function f mapping from R to R is defined by singular function, or such that fx equal to 1 if x is greater than 0. If x is greater than 0, that means y equal to 1. If x is less than 0, y equal to minus 1. And if x equal to 0, if x equal to y is fx is also 0. So what I get? If x is greater than fx greater than 0, that is greater than 0, then y is always y is 1. This distance is 1. And if x is less than 0, if that is negative, this is also minus. This y is and this minus 1, but this is 1. And if x equal to 0, then fx is also 0. So it's called a signum function. Here domain is again all real number, and range is minus 1, 0 and 1. These three values, minus 1, 0 and 1. Here fx equal to mod x by x if x is not equal to 0. Fx equal to, that is y is equal to mod x upon x if x is not equal to 0, and fx equal to 0 if x is at this point, fx is 0, and at this point and this point, this fx is mod x by x. Now next we will teach you greatest integral function. Now I will teach you greatest integral function. What is greatest integer function? A function f mapping from R to R is defined as fx equal to this. This is the symbol of greatest integer. Now in a big bracket, such that x belongs to R, as the assumes greatest. It is assumes greatest integer function. Greatest how? It should be less than or equal to x. Less than or equal to x. Suppose x value is value of x is 3, then it will be less than 3, or equal to less than equal to x. Here this x means the integer value of x means integer plus proper this proper positive fraction. Integer plus proper positive fraction. If it is like this, if it is integer plus proper positive fraction, then you will take integer only. But this graph passes here. These are the observations. This graph passes through origin, and also this graph is symmetrical to the opposite quadrant. Symmetrical to the opposite quadrant. How you take? See, if it is given x, greatest integer x equal to -2 for -2 less than -1, -2 less than minus 1, minus 2 less than x, and which is less than minus 1. Now it is this equal to minus 1 for minus 1 less than, so what is the greatest integer? Minus 1. Minus 1. See, 0 is not there, it is not equal to 0, it is equal to minus 1. So what is this? The minus. What I told? The integer plus positive, proper positive fraction. So here it comes minus 1. Suppose it is minus 1 plus 2 by 3. If it is that means we will take minus 1. Positive fraction. So we will go for minus 1 only. So minus 1 is less than x less than 0. If it is this is equal to 0 for when? If x is greater than 0 and which is less than equal to 0 and less than 1. Here this greatest integer x equal to 1 for x is 1 is less than equal to x which is less than 2. Again here x equal to 2 for 2 is less than equal to x and less than 3. So what is the greatest here? 2 here 2, 1, 0, minus 1, minus 2. These are the greatest integer here because they are not equal to this right side 0, 1. It is not equal to minus 1, 0, 1, 2, 3. That's why we are taking this as greatest integer. This as greatest integer. Now next come smallest integer function. A function f mapping from R to R is defined by fx equal to this smallest integer. For all x belongs to R is smallest integer function where smallest integer is greater than or equal to x. Smallest integer is here greatest integer was less than or equal to x. Less than or equal to x. If value of 3 is x, this integer should be less than 3 or less than 3. So here also same thing. Now the greatest integer or equal to x. The graph is passing through, again it passes through origin and it is symmetrical along two opposite quadrants. Here see how it is. Minus x, if it is minus x, that is equal to minus of x plus 1. Minus of x plus 1. If it is x plus minus of x, that gives 1 if x does not belong to z. Here x belongs to R minus z. That means it is equal to, this is equal to 1 if x is not an integer and it is equal to 0 if x is an integer. Now here x minus minus of x equal to 2x minus 1 if x does not belong to integer and it is equal to 2 if x is an integer. That means that in smallest integer, these are the properties of smallest integer function where this minus of x equal to minus of x plus 1. When it is, if x belongs to R minus z. Here it becomes 1 if x does not belong to z. It becomes 0 if x belongs to z, and x minus of x equal to 2x minus 1 if x does not belong to z, and if x belongs to z it is 2x. With this I am stopping today your graphical representation of your functions. Next class I will take exponential function and logarithm function along with some properties of functions. That will end out the chapter relation and function. Now for further detail you can see my edulog displayed on the screen. Thank you.